Cole Wagner. This is Aish.
Hi.
We are going to be doing the SIG testing intro today. Give you a little introduction to what the SIG does. I'm going to focus mainly on give an overview of the tooling, and then I'm going to mainly focus on what we're doing now that's new. So new features, things that we're working on now. And then Aish is going to talk about applying the SIG tooling that I've talked about to something besides the Kubernetes project. So just first of all, I'd like a show of hands of how many people have heard of any of these things. Okay, how many of you have used them? Okay, if you've contributed to Kubernetes, you've used it whether or not you know it. At least some of these. So just a quick overview of what these are. We have one of our biggest pieces of tooling is called Prow. It runs our testing jobs, it runs our build jobs, it runs publishing jobs, runs all sorts of different jobs for us, and has Git automation as well. I'll go into more detail about that in a second. We also provide some Slack automation, or management tools basically for Slack, since it's not really geared towards the open source community as much as a closed community. We also have Test Grid, which is a grid of your test results in green and red, so that you can get a visual overview of that. Kind is Kubernetes and Docker. Super awesome. It lets you run an entire Kubernetes cluster inside a Docker container. Boskos is a generalized resource management service that we use for provisioning things like clusters on the fly. Gopherage is a really cool tool that lets you run get line coverage using the go test command, but for things that are not actually Go unit tests. So you can run your EDE tests and get line coverage just like you would from a Go test. And the KubeTest is some tooling that we have for testing Kubernetes itself. And we also have a number of tools related to GitHub administration and automation. So a lot of these are running cross-org management kind of things. Yeah, so here's what Prow is. It's a CI/CD system that is built on Kubernetes. It was originally designed for to test the Kubernetes project, but now it is used much more widely. All these organizations down here use it. It's becoming more and more general. Jobs can be triggered by all sorts of different events from GitHub. They can be triggered by cron triggers, pub sub messages, many different triggers. And similarly, there are many different ways that it can report. It can report to GitHub, pub sub, all those kind of things. And it also provides a bunch of GitHub automation in the form of / commands. We have a component called Hook that receives webhooks from GitHub and can react to those in a bunch of different ways depending on the plugins that you have installed. Oh yeah, and we also have something called Tide, which does automatic pull request merging based on configured requirements that have been defined. So I'll go over this real quickly since it sounds like some of you guys are familiar with Prow. One of the core parts of Prow is the Prow job, and it's a Kubernetes CRD, so it's actually stored in the Kubernetes API server. And I'll just walk through a quick flow of what this might look like. So it starts at GitHub when somebody perhaps opens a PR that needs to be tested. That webhook goes to Hook. That webhook then kind of gets muxed to a bunch of different plugins that will determine if the webhook is relevant to their purposes, and if so, they will do something. In this case, the trigger plugin will say, hey, I need to run a new Prow job or a bunch of new Prow jobs, and will create some new CRDs. Doesn't actually do anything besides that. It just creates the Prow job CRDs that describe the jobs that need to run. From there, this controller down here, this Plank controller, is responsible for managing the life cycle of the job and pairing up the job with something that will actually execute it, like a pod. And it keeps the status of the pod in sync with the status of the Prow job. So when the pod completes, it will update the Prow job and mark it as complete as well. Meanwhile, as all these things are changing, Crier is listening to these Prow jobs change, and when something of note happens, it reports. So in this case, it will report to GitHub, but it could, like I said, we have many different reporting syncs, so it can report to PubSub or other things like that. And then at the end, Syncer will do garbage collection, and when certain conditions are met, it'll clean up the Prow jobs and the pods. There are also other ways that jobs can be triggered, which are things like Horologium that handles our cron triggers. So if you have a job that runs every 20 minutes or so, that'll trigger it for you. And Tide, as I mentioned, is our merge automation. And it has to be able to trigger jobs so that it can retest your PRs when the base branch has changed. So if somebody else merges a PR, your PR may not have changed, but when we test PRs, we merge them into the master branch first and test the results of that so that we never actually get into an untested state. Means that we can always be confident that the result of a merge after a PR has been tested and won't introduce any problems. Yeah, and then we also have a deck component. This is what runs the Prow front end, the website, so that you can see the status of your job, see what Tide is doing, stuff like that. Nope. Yeah, so there's more complexity to this, but these are some of the core controllers. Yeah. So now I'm going to talk a little bit more about what's new. This is kind of a list of a lot of unrelated things here, but these are all things that we've been working on as SIG testing in the past quarter since the last KubeCon in December. I guess a little more in the quarter then, but yeah. So this is all stuff since the Seattle KubeCon in December. One of the bigger changes that we did was our job viewing platform, which we previously used something called Cubernator, was switched over to Spyglass, which is part of the Prow front end. So Prow now does all of its own job viewing as well, so you can see your job results without going to a separate site. We have a Tide action history page. So this is a page on Prow that will describe everything that Tide has been doing. So it gives you a breakdown of what its historic actions have been and why. We also have Slack automation, as we mentioned. We have some new tools to help the Slack moderators manage the community and respond to bad events and bad actors in the Slack channel. Kind has matured a whole lot and has all sorts of new features and improved support. Prow now can update itself, which is pretty sweet. It deploys its own images when code is changed. It bumps its own version and will even deploy itself. All we have to do is just give the thumbs up to go ahead and do that. We have a tool called Fano, which allows you to run your Prow jobs locally. So it will convert your Prow job to Docker containers so that you can actually test what your job would do in CI before you have to actually deploy it to CI. Tackle is a tool for deploying Prow. It's just an interactive tool for deploying Prow. And with the addition of sub, we can now trigger Prow jobs using pub/sub messages in addition to reporting to pub/sub. So we kind of have a full pub/sub pipeline now with that. And we've just added support for Tecton pipelines, so you can chain together a bunch of steps and dependent container steps. And there's also been some improvements with Garrett. We can now use comments like /test. So even though a lot of Prow's webhook handling is kind of tightly coupled to GitHub, we're working on moving away from that and generalizing things. I think there are more concerted efforts to do that in a more generalized way, but these are some minor steps that we're taking and realizing that that's high value, so we want to do things in a more general way for sure. Yes, we've also automated a lot of the publishing of our images. So all sorts of test images that need different versions are all now published automatically. So for the Cubernator to Spyglass switch, this is what Cubernator looks like. If you've developed for Kubernetes before, you've probably seen a page like this. This runs on App Engine, and which is not as great as running on Kubernetes, since that's where we run the rest of our CI/CD. And it was also totally separate from Prow, so it was not really great for people who wanted to use Prow for their own purposes because it required additional setup of a separate tool. So we created Spyglass, which is part of the Prow front end, and it has feature parity with Cubernator now, so it's got everything that Cubernator has, but it's written in a much cooler way. All of these different like panels that you see here are essentially plugins that they match it with a regular expression on the files that have changed in the artifacts directory. So basically, if you have a Prow job that spits out all sorts of artifacts, this will automatically identify if it's a file that can be consumed by one of these viewers, and the pane will show up if it's appropriate. So for example, if you have JUnit results, this JUnit section will pop up. This section up here is collapsed right now, but that's metadata about the job. And here's the build log that finds the build log file and displays that with highlighting and all that kind of stuff. Yeah, so that was a great change. Similarly, as I mentioned, Prow can deploy itself now, which is really sweet. So if you follow this right here, this is just kind of the standard workflow for making changes to Prow, and then this is the workflow for deploying it. So some human makes some changes to Prow in a PR. The PR passes test, checks, and review, and then Tide automatically merges it. And we have a post-submit job that runs when the PR merges and triggers image builds and publishes the new Prow images. That can repeat a bunch of times, and then daily, Prow automatically creates a PR that finds the most up-to-date version of the images that have been run, or sorry, the most up-to-date version of the images that have been published, and bumps all of our config to that version. And then when a human looks at that and says, hey, I'm at the keyboard, like it's okay to actually update Prow right now, and all they have to do is approve the PR. And as soon as that happens and the PR merges, another post-submit job detects that we have changed the cluster config and will automatically deploy all that config. So what this boils down to is that all of these green things are totally automated, and these things that are not are things that we really should not automate or cannot. Like it'd be great if Prow could write its own PRs, but we're a little ways out from that. Similarly, it cannot code review, so humans kind of need to be involved for these steps here. But the only other step that we have to actually do to update Prow in production is to just approve a PR. So here's a sampling some of the Slack automation that has recently been added. As I mentioned, Slack is kind of geared towards companies or closed organizations, which is very much the opposite of the Kubernetes community, where we try to allow anybody to come into our Slack channel. So to keep it that way, even with bad actors in existence, we have to have some automation to be able to report things. This is in particular important because before this there was no way to actually report anything that was inside of a direct message. You can only report things in public channels because direct messages are not visible to any moderators. Similarly, it was basically impossible to deal with bad actors who were writing bad messages because it took 2 clicks on different parts of the screen for every message that they added to remove it. So that means that if somebody was typing bad things, they can very easily type them faster than you can delete them, even without using any sort of automation to be, spamming. So this is a tool that allows a user to be banned and have all of their content for some recent amount of time removed. Similarly, we needed some sort of event log so we could have auditing of what was happening in the Slack. So this tells when channels are created, teams, stuff like that, and the emoji changes as well, which are critically important. Here's the Tide history dashboard I mentioned. So if you want to see what Tide is doing, how it's choosing to merge PRs, you notice that each one of these sections here is another cycle of testing and merging. So in this is the base branch SHA that I was talking about, so we want to make sure we're always testing against this most recent SHA. So if you notice, every time something merges, a new section begins, because the base SHA has changed every time something merges. So this is a good view. Like this is kind of the healthy, happy case right now, but it's a good way to see if Tide is getting stuck on something or why it is taking a long time. Maybe you can see that it's maybe triggered a lot of batches repeatedly, stuff like that. But it gives you a breakdown of what's going on, and if there's errors in any of these steps, error messages will be included as well, telling you why things didn't work. And as I mentioned, Kind has improved a lot. It is reached maturity for the most part now. I'm sure it's still being worked on, but it is dramatically more useful than usable than it was in December. It is mainly because it has support for so many more things. I think there's been 3 of the 4 releases of Kind have been since December, so there's been a lot of active development there, and the community's been growing extremely rapidly. I won't list off all of these things, but you can see that there's just a laundry list of new additions and improvements. So here's what we're up to now. These are things that we are either working on right now or things that are on our 2019 roadmap that we plan to address this year. One of the major things is supporting more Git providers and code review platforms. So as we mentioned now, Prow is kind of tightly coupled to GitHub in a number of ways. There are other parts that basically the job execution is not really coupled to it, but all of our triggering logic is, or a lot of our triggering logic is, and all of the plugins that do things like /LGTM or /approve, all those kind of GitOps plugins that we have only work on GitHub. And we'd like to be able to make that more general and have anything like GitLab or other Git and code review providers work with that. We'd also like to improve our metrics and alerting. Right now it's kind of cobbled together, and it kind of works, but it could be a lot cleaner and smoother and deliverable to any users of Prow. We'd also like to make prow.kh.io managed by the open source community. Right now it is managed by a team of Googlers because the cluster's on a Google-owned project. And all we really need to do is be able to move that over, but there's since this is such a huge amount of infrastructure and many projects related, related to it, it's a very large effort. We also want to improve self-service of config so that people can have their job config in the repos where they're using their jobs. Make it a lot easier instead of having to go to a test infra repo or like a CI repo where you have to edit your job configs. Doing that in repo would be simpler. And GitHub Enterprise support would also be great. Kind is also working on some changes too. Faster startup and smaller images with containerd. Restart support's really big. Yeah. So yeah, that's my part. Let Ice take over now.
Cool, thanks. So thus far, Cole spoke about how the various SIG testing tools such as Prow and there's TestGrid as well and a bunch of other things are used to improve developer productivity for open source projects. So I would like to switch gears a little bit and see how can we extend and adapt some of these open source tools to help us qualify our internal projects. Specifically talk about a case study within Google, like how we extended these exact same tools to work with a hybrid cloud project that we are coming up with right now. So that project is called ANTHOS. So what is ANTHOS? The cloud landscape itself is evolving quite fast to include hybrid clouds, where we run workloads both on customers' on-premises environments and also on cloud. For any huge customer, such an enterprise customer, lifting and shifting their workloads completely to the cloud at once could be extremely daunting. And most of them want a hybrid solution. And towards this, Google announced ANTHOS, which is our multi-cloud effort, which aims to take the goodness of Kubernetes clusters to the customer's on-premises environment so that they can modernize in place, build and manage applications at scale that can run on multiple clouds. So there's a lot of words and things in there, but what it provides test infra is it provides an extremely challenging landscape and also a lot of opportunity to bootstrap CI that could test the product continuously in a hybrid landscape. So when we had this challenge like about 6-8 months back right now, we took a pause and we, instead of like reinventing the tools and building everything from scratch, we wanted to see how much of the open source tools can we repurpose for this purpose. And the idea here is by giving this overview, it might give some insight for folks out there who might want to repurpose these tools, and that will give them some insight into how they can adapt and adopt these tools for their needs. So this is a little bit about the landscape. In OSS, we develop on GitHub. We use Prow to build and test and verify things on GCP, and then we release using Cloud Build. ANTHOS, as you see at a very high level, is very similar, but instead we use Gerrit and internal Git on Bob repos for our development. And the deployment, as I said, since it's an on-prem project, we deploy the cluster on vSphere. So why did we want to reuse SIG testing tools? For any project, before we launch into it, we define the success metrics. What are the things that we are trying to optimize for? So for ANTHOS CI, these were our ground states. As of now, ANTHOS is a very fast-moving project. We have continuous releases, and we have a very large Google developer community internally contributing to the code base quite rapidly. So it was crucial for us to qualify the binaries reliably and in a continuous manner, while still enabling the developers to be as productive as possible. Towards this, we wanted the tooling to be quite intuitive, easy to adopt, something that came with instructions and provided an ability for them to self-service themselves. We wanted the tooling to be reliable so that we can build and maintain developer trust. We also wanted a great support and SLA from the folks actually owning and building these tools. If we had feature requests, we wanted them to be able to be met at a very reasonable time frame. And we also wanted solid test result reporting mechanisms. So we were a lot greedy here, but we had all the SIG testing tools to our rescue. SIG testing, as Cole spoke about it, they've been working in this space for quite a few years now. They've built and matured tools exactly for this use case, and also the SLA and the community around building and maintaining these tools is quite active. Hence it fit our bill, and we started using those tools for our purpose. So here's a quick overview of what we added, how we use those tools, and what we added to them. So we chose Prow as our CI framework. A little bit in the first slide I alluded to that we deploy our ANTHOS cluster on vSphere. So which means we needed Prow to run in the vSphere test lab to test our product. At least at the time when we started this, we didn't have a very clear, easy, or written down documented way of bootstrapping a Prow cluster in vSphere. So we went the typical, the Kubernetes way of testing things, and we decided to test ANTHOS and ANTHOS. So by this I mean is we bootstrapped an ANTHOS cluster in our vSphere lab because that's what the product does and it's supposed to work. And then we deployed Prow onto this cluster. As Cole pointed out, we have multiple instances of Prow that's being used by a lot of other companies. So we also built our own private instance of Prow. And that's where our CI runs to run periodic and pre-submit jobs on our ANTHOS binaries continuously. So this helped us not only dogfood the product, but also net a lot of those elusive bugs that only manifested when a cluster ran for a long time in long-running states. So once we did that, we then had to, in order to help developer productivity, we had to bring our internal instance of Prow to somewhat of a feature parity with the open source Prow. Because a lot of our developers, again, they were used to the open source tools, they were used to a lot of features there, and they expected those to work on internal Prow too. For example, they wanted Prow, once it finished the pre-submit, they wanted the test results to be reported back to the CL, similar to what we have in open source. And they wanted comment-based triggering of some test jobs, similar to like the /retry/ commands that we have in open source Prow. So this gave us an opportunity to contribute back to open source. And this is where the whole part of adopting and adapting the tools come into picture. A lot of these open source tools, they are built in a way where you can easily extend them using plugins and using config types. So any open source developer out there can actually take advantage of these models and work with the community to actually build the features that they're looking for. And once that gets released in open source Prow, it becomes available in your downstream version as well. So a few contributions that we made was we built the ability to post results back to Gerrit because Gerrit was a code review tool, after the pre-submits are run. We made some open source contributions to Crier, which Cole again spoke about. So we built a Gerrit plugin for that. So when testers issue a /test command, it actually goes and runs specific set of tests, end-to-end tests against their CLs. We also built post-submit hook for Gerrit. We already had it in the OSS version, so we extended this to work with the Prow that works with Gerrit instance as well. And once the cluster is up, as to qualify the health of the cluster, we run our open source conformance tests because similar to what we do in open source, we want to make sure that when we call a cluster Kubernetes cluster, it passes the conformance. And all of you, again, those who work with open source Prow will be quite aware of how it hand-holds your PR through various iterations of test and review. Similarly, the internal CLs as well, whenever there is a new packset that is packset that comes into an incoming CL, the internal version of Prow, it triggers a set of Prow pre-submits job on it. And then there's the /test command, which again, that's the one there, where they can issue a specific test job they want to run, which then runs the end-to-end test and then post the results back to the CL as well. And as you can see, in both cases, the Prow bot either upvotes or downvotes the specific Gerrit labels, which in turn will either block your CL or let it merge. The other open source tool that we kind of repurposed for our need was Boskos. For those who have, again, worked in open source, Boskos is our resource rental system, which lets you manage checking and checking out of any entities that you define as Boskos resource. In open source, we use it to rent out GCP projects to run our tests on Kubernetes. So we use Boskos to actually rent out IPs that we need to bring up the cluster. So in case where we don't need these IPs to conflict in our different runs, we manage that through Boskos. And also in some cases, we rent out the entire ANTHOS cluster to speed up our tests when we do non-mutation-based tests. And we also, in open source, there's also a janitor that comes with Boskos, which basically runs periodically to release any leaked Boskos resource. For our need, we kind of repurposed this, but built a whole bunch of, how do I say, we made the janitor a little bit more loaded. Rather than just reaping the Boskos resources, we kind of hacked around it to make it a more of a periodic job that runs and reaps any kind of CI resource that's left behind from a previous run. Since our clusters are more stateful, we want to make sure that any IPs that's leaked or any partitions that leaked are kind of cleaned up before the next run rolls in. Cole spoke about Spyglass. Since we use the latest Prow, we get all the goodness of Spyglass for debugging. TestGrid. TestGrid is yet another really successful SIG testing tool that's used very widely in open source, which is the de facto dashboard to publish test results. And we have an internal instance of TestGrid to which we send all our periodic and pre-submit results to. Another cool thing is, in addition to publishing test results, TestGrid also helps surface some test metadata similar to which commit it ran, what's the test duration, and you can also specify some key metrics that you want to track, for example, code coverage, unit test code coverage, and things like that. So we also use TestGrid to actually alert if there's any regression in terms of test results or also like the key metrics that you're tracking. So we have automated emails that go out to our on-call areas or folks who are actively watching the test results to make sure any functionality regressions are caught early on. We also further extend this by failing merges of CLs if they actually drop the unit test code coverage beyond a specific threshold. So this helps us build and drive test discipline right at the beginning and helps us triage issues much faster. And we also have a bunch of Grafana dashboards that we use to track CI usage and lab metrics. In open source, we use similar dashboards to track the top flakiest jobs or the failing jobs in Kubernetes tests. This is a similar concept, but we use it to track our CI usage. Some top usages that we track are, at any given point, how many pre-submits are running, how many Boskos resources are we using, at any given point, how many failures do we have in pre-submits. We are pretty early in this game. We kind of want to go ahead and build some more metrics, especially around flake rates, so that we'll be able to say if a failure is systematic or if it is related to a specific CL or what the case is there. In addition to tracking CI usage, another component that really is important for our test health is the lab itself, the vSphere lab itself against which we run. So we also track some of those metrics such as disk latency, device latency, queue latency, and everything. So having these two data side by side helps us correlate a lot of things. For example, when there is a spike in the pre-submit failures, we go to the lab usage metrics to see is there a disk that is misbehaving, or does it have like more pressure that's causing widespread failures. Or it also helps us to be a little bit more proactive, as in if we see that the pre-submit loads is increasing, what is the tipping point at which our lab goes down? This helps us capacity plan for the lab much better, and also redirect our workloads to different disks. Okay, so tying it all together, so our aim was to build a stable test infrastructure that helps us to reliably qualify ANTHOS binaries, enable the various dev teams to integrate their tests into our CI pipeline, build test best practices and testing gates to qualify things, and all of this ideally goes into providing a no-go-no release signal. So just to, you should have a flow chart, you should have, show how everything flows together. We have our development CI and our reporting blocks, if you will. And we develop on Gerrit, and we have Git on board, which is basically repos, which are our system under test, and all our reporting goes to TestGrid. We have our vSphere test lab, on which we have our own instance of Prow running, which listens to Gerrit API for incoming CLs, and once there's a CL, it checks out code from our repository, builds your changes from the with head at that point, and then leases out resources from Boskos to spin up an ANTHOS cluster, and runs your open source conformance tests, among other things, to qualify the health itself. And then all the results go to GCS, from where it's getting pulled by testRed for reporting purposes. And all the results, Prow then post the results back to Gerrit again, so developers can take subsequent action, which is if the test pass, they can merge their changes in. If not, they rinse and repeat. And every 4 hours, this is the horologium hook that Cole was talking about. We have periodic jobs that run every 4 hours and sometimes even frequently depending on the job, which checks out everything from head and does the whole CI testing again and then pushes the results back. So in conclusion, so far we've been successful in reusing the open source tools for our needs. The SIG-Testing team is, again, as I said, is building these tools and working at it currently to solve most of the problems that we encounter internally as well. So they are doing it so that we don't have to repeat the same thing. So this talks a lot about the maturity of the ecosystem and how far the tooling is come. So the next time you have a need internally, I would request to pause and think if you can reuse rather than reinventing it. And this is where you can find us.
Yeah, these are, if you want to get involved with SIG testing, whether or not it is for the Kubernetes project or to apply these tools on your own, which is a surprisingly large fraction of our contributors who want to use these tools and are helping everybody just by contributing. We have, our SIG has weekly meetings on Tuesday at 1 p.m. Pacific time. We have a mailing list, and we have a number of channels in the Kubernetes Slack. Those are our repos down there too. So if you want to get involved, we're always eager to have new contributors. So just reach out. Thanks. And all these links will be on the slides, so those will all be available.
Questions?
Yes, how much time did it take you to make Prow working with ANTHOS, and if you can share how many people were working on it?
So for us, the trickier part was not to deploy Prow on the cluster. That part was pretty much self-service, and then we do have an active community here unblocking us as needed. But for us, the trickier part was getting, this was at very early stages of the project. So to even get a cluster up and running continuously with ANTHOS was the harder part. So the more time was spent in like getting a viable cluster in vSphere running, and then deploying Prow on top of it was pretty much just following the manual and resolving the roadblocks as we get there, which weren't many.
I know there's been some conversations about, so for example, Kind is not part of the tested for a mono repo. It's kind of managed as a freestanding project. I know there's been some conversations about doing the same thing with Prow. Is that going to happen? Is that, Eric is giving a very, that may be unrelated. But
Yes, it should happen. I don't know if there's any good reason that we haven't done it yet. It would make a lot of sense. We can then decouple our prow.capes.io config from the actual Prow code and make sure that that'll help us follow a better pattern, because that is what everybody else should be doing who's using Prow. Yeah, I don't think there's any good reason for us not to do that. I think we're planning to do that. It's just not been actively worked on quite yet.
It's a lack of resources dedicated to it. If you want to show up and help us do that, that would be fantastic. It's not priority.
Yeah, I think everybody wants to do that though. That's totally the right way to be doing that.
okay.
Yeah.
Is there any support for GitLab in Prow? Because I think I saw that there were plans for that. So is there any work started, or is just waiting for someone to show up and help?
I can answer that.
Yeah.
Yeah, we're working on that. We've had some, as Cole mentioned, there are a lot of things that are tightly coupled to GitHub. So we're, my name is Will, and I work for CloudNativeCon. I work on the Jenkins X project. We use Prow Jenkins X. And so myself and a guy named Cosmin, who also works on Jenkins X, are working right now to get that all sorted out. So it's been a bumpy road, but I think we're getting close to getting that, to being able to support your favorite kit provider in that so.
Yeah, I think we're out of
Well,
time
thank you
too.
very much.
Thank you.
Thank you.